Hello, let's continue on with talking about transactions. Now, transactions are really a huge part of why we have databases. They're really sort of at the core and the center of what's really important. So this is the material we're going to talk about in section 4.3. Now, I want to note, though, that the textbook that you have, chapter 17, is an entire chapter on transactions and really gets into the fundamentals as well as their implementation and the theory behind and how all this happens. We're just going to talk about the concepts and that we can actually do transactions in our database. Actually, a lot of what we build in 245 and then 342, these two courses, I'd be surprised if we have a huge need, if you run into a project where you're like, oh yeah, I need to do this as a transaction. Now, you're going to be using databases constantly, and every single SQL statement you do will be a transaction in and of itself. And you rely upon that so that you can get all the good properties and maintain the data so it actually works the way you think it's going to work. You need this these transactions built into the system. But as we'll talk about, you're probably not actually dealing with too many things where you have multiple steps and you bundle them all up in a transaction. That's not quite as common. Some of what I will talk about is going to be based upon what we see for the actual database that we're using in the course, the Postgres. So if you go to postgresql.org/docs/current, meaning their current version of the system, and that's what we actually have installed and running on. Codio is version 13. When we start deploying things to Heroku, it's also running version 15. So we're up to the latest standard for this, which is nice. They have a small little tutorial, and I mean small. In other words, it wouldn't take you long to read this web page, not more than a couple minutes. So tutorial-transactions.html. I recommend giving it a look. You know, especially if what I talk about, you're like, huh? Or you don't like what the textbook. This is a really good, clean source of information about this. So as I said, they're fundamental operation to databases, and there's really two big parts about what transactions are doing for us. And we've talked a little bit about this in the very introduction to databases. But first of all is this notion of atomicity. So we want our actions, our commands that we do with our database, these inserts, updates, and even our selects to be atomic. Okay, we want them to either happen or not happen. We want sort of, now you don't see this because you're doing a single operation. But again, you can have multiple operations and you want to be able to bundle them together. So you want all of those operations to happen or none of them. All right. And so you're like, all of these changes I want to make to the database, they better all go in or none of them. I don't want some of them to work and some of them not to work. That will leave my application in an inconsistent state. I'll have strange data. That's not what I want. So I need this ability to say, here's a set of operations, do them in an atomic fashion. And by the way, I said, oh, it's a single statement. But think about a select statement where you're returning multiple rows. You really want that to be, it's like it's an atomic action. All right, you don't want the data as you're selecting it to change underneath you and part of a row to be from one point in time and another part of the row to be from another point in time. It's like you want to like freeze time in a moment. But that's really what I'm talking about there is a little bit more dealing with isolation. All right, so let me not try to confuse you. But so isolation is the other really big thing. And this gets stated as, if we have two transactions I think I pulled this material from chapter 17. Transaction I, transaction J. Then, even if they execute concurrently, so concurrently meaning they are executing at the same time, it will appear that one or the other executed first. And we're not guaranteed which one will be given priority in this. In other words, if two people, let's say, do something at exactly the same time with that database, and that means they're going to be two separate transactions. One of them is going to be run and appear to have happened before the other one. They might actually happen at the same time, but the database is going to make it seem like to the user that one of them in time happened before the other one. All right, so they're isolated from them. So one transaction is isolated from another one. And so that's when I was talking about, like, you do this big SQL statement and you select, let's say, 1,000 rows. You don't want in the midst of that statement someone else's update coming in and changing part of your data. You want it at the time that you issued that query that all of that data is consistent, okay? And so it needs to happen that you were like the one person in that moment of time, and that's the state the database was in. Sure, someone else might be doing something at the same time, but from your perspective, you get to see it as though everything was proper. One of the things that's fascinating about this is that every single command that we've been issuing, these selects, inserts, updates, and deletes in Postgres. All right, so it operates in a mode that's called Autocommit. And basically the idea is that when we issue a single SQL statement, they are wrapped in a transaction and then committed. Okay. There are other databases out there, such as Oracle, which by default do not do this. I don't know if I want to admit this in a public recording, but I will. When I worked at my first job post university, you know, I did not know as much about databases as you will know about databases after 245. But I had the job, they gave it to me, and we were working on a web application, and the database was Oracle. And as you'll read about in the textbook, Oracle by default does not have auto commit turned on. I'm not quite sure why. I think almost every other vendor does have auto commit on, and I think it's because it's the way we think it should work. So I don't know why Oracle had that notion. Nevertheless, I wrote this web application, and it was running, and it's all with a database. You know, everything going on with all these users and the data they're inputting and this and that. And so, yeah, I'm making all of these inserts and all these sorts of changes and updates to the database without any understanding that Oracle wasn't committing any of it to the database, because it all looked like it was there to me. What was happening is that each one of these things I did was part of became part of this transaction. And so Oracle, to maintain those properties of atomicity in isolation, needed to keep track of this and needed to keep track of the state of the database for all these open transactions that I had created. And I came in one morning, and our database administrator, bless his soul, I saw him off over the other part of the room, talking with like the VP of engineering, furious about these stupid engineers, and there's and I've been trying to resolve. And so he had an ability to go in and find all these open transactions, and he was like commit, 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 commit. And then it was taking forever for the database to properly update and everything. And I realized, oh, wait a minute, that's probably me. I put it 2 and 2 together. And because, he said something like, don't they know that they need to hit run commit, after they do their queries? And I was like, they do? What? Huh? And I went and I checked and I realized, oh my goodness gracious, what a stupid thing I've done. And I quickly went into the code, added a whole bunch of commit statements. And I think I was too embarrassed and too young to go over there and apologize and admit my mistake. I guess this is my public apology now. I apologize to our database administrator for the stress I caused him. So keep that in mind. Thankfully, Postgres isn't gonna behave the way you think. But if you ever go work for an Oracle database or some other database, you should always check, is Autocommit on or off before you do stuff, because you might be responsible for committing. So what does this really mean? So the way we do transactions in Postgres, and this is another thing, is a lot of these details are not really specified by SQL. So it's not like SQL always has everything written in stone. Each database vendor makes changes to the language or has to implement things their own way for their implementation. So you always end up having to read the documentation for the vendor of the database you're working with. Anyway, for Postgres, the way that we start a transaction is we issue a very simple SQL statement, which is just simply begin, semicolon. And this says to our database, I am now starting a transaction, and until I end this transaction, please give me this sense of isolation, and as well, either all of my commands will work or none of them, all right? And so then you can go ahead and you can write statement after statement after statement, and eventually, if you want to, basically the idea is you want to save all your work in the database. That's when then you end with a command commit, all right? And one thing to note, if any of these statements in here produces an error, the whole transaction's off, okay? And so everything will not actually get committed if any of them has an error condition to them. And and you can have an error condition with you try to do something and you use the wrong syntax even. Nope, no good. Something was wrong. Then another notion, so we can also, let's say we're going to run something. So we're going to do our transactions, begin, we do our statements. Now let's say in the midst of it, it's not an error occurs, but we write logic and we go, wait a second, something's not right here. I don't want to commit this stuff to the database. I'm going to bail out of my transaction. The way that you bail out or cancel your transaction, so this is like canceling, is to do rollback. Roll it all back. So you've been keeping track of all these changes I've been making. Yeah. Undo them all for me, please, and leave the database in exactly the same state as when I started doing this. All right. So one of the nice things, by the way, you can do these things, you can do transactions in PSQL. So in the command line interpreter, where we actually get to interactively query and use the database, you can go in there and you can type begin semicolon, and you'll see the prompt subtly change. It'll go from just being a hash mark to a hash mark and a star, and that means you're in the midst of a transaction. And you can go along and then you could decide to commit if you want, but that's not really necessarily the huge advantage to you. The huge advantage is you can go in there, you can do begin, and you can write, delete update. You can make all sorts of changes. You can practice changing the database. And if you run selects and stuff, you'll see those changes happen or not happen. But maybe you'd make a mistake doing it. Maybe you don't like that. You could try out these commands, and then you can do rollback, and they all go away. No questions asked. No one needs to know any better. So this is a way for you to try out destructive commands without actually changing the database and do it in a safe way. So this is a really cool thing. You can, go in, do begin, do some statements. Again, if you make any errors, it's going to be all off anyway. But then you can type rollback, semicolon, and they're all gone and they're done. And eventually you'll be like, I have all my commands figured out. And then you can actually go and do your commands for real and commit them. All right. So let's talk about sort of a real example to try to get this to make sense. Yeah. So classic example is about transactions, is about transferring money between accounts. But I'm actually not going to talk about transferring of money. If you want to see the transfer example, look at textbook, look at the Postgres example just about everywhere. Likewise, another classic example is imagine an airline. And, you've got seats in a plane, and someone's going to buy a ticket and pick a seat. You want to be sure that only one person gets put into that seat. So databases and transactions are critical for that sort of thing. But here, so let's give an example about money. Because I think transactions are so important that we really get a sense of it. So let's say my scenario is we've got two people with a joint bank account. And they're both out shopping and they're going to buy something with a debit card. All right. And so one person is going to buy something worth $100 and another person's going to buy something worth $75. And they both end up at the checkout at the same time. They're not at the same store, most likely. They're at different stores. It's like a married couple. One has gone to one store and one has gone to another store. Anyways, and so you could envision that when they go through that checkout and they're going to use their debit card, person one is going to be doing something effectively that we're going to have a SQL statement that needs to run, which is update, and let's say we have a table accounts, and we're going to set the balance in the account equal to the balance minus the cost, which is $100. And yes, we need to be sure that we change the correct account. So it's where the ID is. Let's just say it's account 22. All right. Person two comes in. We've got the same statement, blah, 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 except it's minus 75. And then you have the same where clause. Okay. So we've got person one is going to take $100 out of the account. Person two is going to take $75 out of the account. Now, let's think about what's going on inside of that database. So inside of that database, you've got, in the database itself, you've got some table with a row. And in that, it says the balance. I'm going to go ahead and say it's starting is 100. Okay, so the balance currently, unfortunately for this couple, there's not much money in the account right now. Who's going to get to spend it first? Well, let's think about what the issue here is. So we basically have this scenario. We're going to start off with $100 in the database table. and they're both at the checkout. They've both put in the debit card, and they're like, boom, yeah, do this transaction. So both queries run at the same time. And so what's going on inside this computer server that's running these concurrent queries for the bank? And it's getting a request to, yep, debit this account $100, debit this account $75. Well, and again, the computer is not running in a sequential fashion. The computer has multiple threads, multiple processes. It's going to concurrently process these requests. And again, it's handling all these requests all over Ontario and the world. You know, it's a very big computer. All right. And so what it has to do is it's going to go and pull out of the file. So this is inside the database. It has to pull out of the disk system, the file system, out of this file, what the balance amount is. And then it has to bring it into memory. So in memory, it goes and it pulls in that there's $100. And so in a variable, just like a program you have, it knows, oh yeah, I got $100. There's also, it's in the database, you know, our little cylinder on a hard drive somewhere is written $100. And so we had to read from the hard drive and bring it into memory. So this is person 1 here. And we've got person 2. This again, they get their process that's running in the database also brings in that amount at the same time. They both read it in. So this thread or process thinks there's $100. This one thinks there's $100. They both read from the database. All right. So, and this is what happens. So this example here I'm going to show you is what happens if we don't have transactions. All right. So this is an example. What happens without transactions? So you're processing these two statements, you're reading things in. You don't have any logic here for transactions. You're just like, yep, we both read the data in. And so now you've got some code. And let's say, you got that code and you're like, yeah, I have to take this variable balance and I need to subtract 100 from it. And then I need to assign it back into the balance. And over here, this program's doing the same thing. It's got the balance and I have to take the balance, this variable, and subtract 75 from it. And then they both have to save the new value back to the database. They have to get it back into the file. So they have to save the balance to the file, which is to the database. All right, so that's what they're going to do. Well, look, what if person 1 gets to run this code first? Fine, that's not a problem. In fact, they run it and it becomes 0. And let's even say, before this one happens, this person over here got to do theirs, and so this becomes 25. No problem. This program over here thinks the balance is 0. This one thinks the balance is 25. Now, one of these commands is going to get to go first. Oh, let's say this one goes first. All right, so they go and they write out to the database that the balance is 0 now. So that's all saved to the hard drive. That's one spot on the hard drive. Oh, it's now 0. Oh, and then a fraction of a second later, this code runs, writes out and saves 25 to the database. All right. And now the balance in the database is 25. Now this couple is quite happy. They've just spent $175 and they started with $100 and they have $25 left in their bank account. The bank is very unhappy. Okay, so we need transactions such that this statement happens and then this statement happens, or this statement happens, then this statement happens. We can't have them happen at the same time, but we don't want mandated serial notions. We want everything to behave and act as though it is concurrent, such that we have maximum performance for our database. So it's actually quite complex. But transactions protects us and handles this sort of stuff. So the big thing is, as a user of a database, as a developer using the database, you get to go, I don't have to figure out how this is done, but I just get to simply say, update the balance, do it. And to know that we will always properly end up with the proper amount in the database. So yes, if this one went first, then we would end up with minus 75. If this one goes first and then this one goes, we would end up with minus 75 in the bank account, and we'd get to, the bank would get to charge them a fee, and all sorts of horrible things would happen to the couple, but at least the bank wouldn't be out of money. All right, maybe I should have started them with a larger balance just to be nicer to them. Anyways, but from your developer, from the engineer standpoint, it's like, wow, this database has saved me from so much trouble and headaches. I get to have this atomicity, I get to have this isolation, I get concurrency. I'm just responsible for making sure I manage my application so that the data is all consistent and everything. But yeah, it's great. And as well, it's durable. So it actually gets there on the disk, or it didn't get, and then the whole thing is told to me that it didn't actually work. So we only find out that our commands actually have been successful once the database confirms that it has a durable written answer to the database, such that if there's power loss or whatever, the actual change that we made to the database actually has happened. Without that, we could think that we had changed the database, something happened, but it didn't really happen. No, the database handles that all for us. We get this atomicity, we have to deal with consistency ourselves, we get isolation, which gives us concurrency, and we get durability from the database. This ACID property is all about good database applications, and most of that is handled for us by the database, and we don't even have to think about it. It's absolutely fabulous. I want you to, again, note that you can try this out in PSQL. You can absolutely open up 2 terminals in Codio, start PSQL on one, start PSQL on the other, type begin in both terminals, and do an update to a row in one, and then do an update to the row in the other. Or do an update to row in one and do a select in the other and sees what happens. Then do a commit or do a rollback and see what happens to the other. You can play around with transactions. It's totally cool. I love it. All right. At least I had a lot of fun doing it in PSQL when checking all this out. Okay, so yeah, that's what I wanted to say about transactions. Great.